lab equipment usage.
Ah, very good. Hey, hey. For unit 2, accuracy and precision.
I was talking about it the other day.
Now, let's do an example, okay? If the real value is 3.56, whatever, density, whatever this value is, this is the real value. And while doing an experiment, a kid gets these results. What can you tell about this data?
It's neither precise nor.
Very good, precise but not accurate. Now, can you tell me what kind of error this kid would have done? Would it be a random error, a systematic error, or human error? Why would you select systematic?
Because all of the answers.
Very good. What is random error?
One of the.
An outlier. So if one of this would have been a 6.3, other one would have been 5.9. Now I would say, this is all over the
Human
place. Not
error.
accurate, not precise. But at the same time, this sounds like a random error to me. Does it to you?
What would be a human error then?
A human error is when you take something and you drop the mass of something, right? You drop something and then
How do you tell?
it'll be described in a question. It'll be described in a
And
question.
then random is when like the environment somehow changes.
Correct. Then you have no control over it. Like there's a draft
Yeah.
while massing something. What can you do about it? Types. Okay. So that is your. So that there will be a question like that. Okay. Absolutely. On accuracy and precision. Yes.
Wait, what's accurate but not precise?
What's accurate but not precise? This is.
I don't think you can.
It's not possible. So look at it. This is your target. I hit once here, okay, but then I hit here. So you cannot have something that is accurate and precise. Accurate and precise is possible because every time I hit the bullseye, that's what it means. But the other option is not possible. Okay, next, accuracy, precision. Then comes rules for addition and subtraction, multiplication, division for sig figs. When you add and subtract the number of digits after the decimal, and when you multiply and you divide number of sig figs, least number of sig figs is what you report your answer in. There will be a couple of questions like that. Yes.
For addition, subtraction, it's like number of digits after the decimal for which one? Like the lowest, the least number.
Least number of digits after the decimal.
Can you
Yes.
show us the America one thing?
Which one?
The America thing? Pacific Atlantic.
Oh, America one. Okay. Pacific Atlantic rule. You love it when I draw the map. Pacific Atlantic. Okay, Pacific means point
Present.
So now if it's this is the number and they're asking how many sig figs in it. Point present means you start from the Pacific side, keep on knocking things out till you reach the first non-zero digit. After that, everything is significant. So how many sig figs? 1, 2, 3, 4. 4 sig figs. Yeah? Now, if there is point absent, so you have point absent. Start from Atlantic and then keep scratching out the zeros till you reach the first non-zero digit. After that, everything is significant. So 1, 2, 3, 4, 5, 6, 7. 7 sig figs. Yes.
When there's a question not specifically on sig figs, but like, I don't know, calculating something, should you still use sig figs in your
Okay,
answer?
the rules are you should use sig figs, but conversion factors do not contribute to sig figs. When you find percentages, you times it by 100. The number 100 does not contribute to the sig figs. Constants do not contribute to the sig figs. How should you answer your, should your answer be in is least number of sig figs given to you in the problem, whatever you start off with. Dimensional analysis. you need to know conversions from meters to centimeters, centimeters to meters, meters to kilometers. King Henry died unexpectedly drinking chocolate milk. Do you remember that, King Henry? Okay. So you need to do your conversions also. This is the same unit, right? Yes or no? Okay, what else is in this unit? This was a cute little unit.
Convert between standard and scientific notations.
Okay, standard and scientific is 10 raised to, you know why you use scientific? So that your numbers become like, you know, a smaller number. And secondly, it helps, reduces your errors with the sig figs. Scientific notations are always good so that you don't make mistakes in sig figs. Anything else in this unit? What have we done so far? Dimensional analysis and moles. Now moles to grams and molar masses. Please make sure you read your periodic table correctly. The bigger number is the mass number of the two. Add them up correctly, molar masses, and then convert moles to grams. You need your molar mass.
And then also it says like compare and contrast elements, compound solutions, and heterogeneous mixtures.
Correct. What is an element? What is a compound?
Element if it's the
Is what
same
you see on the
atom.
periodic table is the element. When they combine, elements combine to form compounds. Absolutely correct. Now, your compounds then could be heterogeneous or no, what's the heterogeneous mixtures and homogeneous mixtures. Heterogeneous means that the two things that are combining can be separated out. Correct? Like orange juice with pulp. The pulp doesn't, like, and it's not homogeneous. It stands out. Similarly, so that is your heterogeneous. Homogeneous is something that combines, like sugar water. Sugar goes inside of water and it's a homogeneous mixture.
Well, we have the chart on the chart, yeah. Do you memorize the chart?
No, you should just know your heterogeneous, homogeneous. You don't need to know the
You don't
chart.
need to know like the different.
No.
And then it says manipulate.
But it's a good thing to study from it. I gave you your written part of the test back
Yeah.
a while ago. That you should study from that.
Okay.
But nobody's going to ask you for the chart.
Okay.
Okay, good with unit 2?
Where gonna be error analysis?
There won't be error analysis, but the way I showed you, what kind of error is it, is what they'll ask you, systematic or random.
Separation of mixtures also.
Separation of mixtures, yes, it's a good thing to know. How do you separate mixtures? Chromatography is one, distillation is one, and filtration is another process. Do you remember that? Filtration is just filter. You filter your orange juice. If you don't want the pulp in it, you just filter it, right? Through a sieve. Yeah.
It says manipulate the density formula to solve density problems.
Oh, you just move it around.
It's just density is equal to mass over volume. Density is equal to mass over volume. You just know the formula you need to just plug in. Yeah. Intensive and extensive property. Those words are good to know. Intensive means that it is mass dependent. You can go. It is mass independent. That means it's not dependent on mass. For example, density. Yeah, you can. She'll send you the video. Yeah. I'll say hi. Hi. What's his name?
Andy.
What?
Andy.
Andy. Bye, Andy. You missed out on a lot of
Yeah.
things.
Wait, I
You
don't
will
have your
get it
number.
too. Timothy.
Just intensive is not.
Intensive is not dependent on mass because what it's like, you take a big chunk of gold and you take a small chunk of gold. Got it? Brick. They both will have the same density, so the mass does not affect the intensive property. That's what intensive is. Good?
Yeah.
Okay, unit 3.
Wavelength, frequency, energy.
Ooh, this is a big unit. I
This
know.
was an
Unit
easy
3.
unit, guys.
But you know what? We are 3/4 done. How about that? Unit 3. Unit 3 was all about light. Do you remember that?
The unit.
It is a deadly unit. E is equal to,
This is the good unit.
this was the good unit. What is that formula? Lambda is equal to C times nu. Correct? Yes? Do you remember that?
Wait, wasn't it C equals?
Yeah.
Oh, you're right.
Right, yeah.
Okay, I was
C
like.
is equal to lambda times nu. Okay, good. I'm losing it. Okay, C is equal to lambda times nu. Absolutely correct. And then what nu is equal to C over lambda.
Wait, no, yeah.
It's the same thing. Just move it around, yeah.
Which is which?
Which is which?
What?
Which is what?
C is a constant.
What is which?
Which is
I have no clue. Which is what?
U is frequency.
Okay, C is the speed of light. Lambda is the wavelength. And nu is the
Frequency.
frequency. Now, you have to know your electromagnetic radiation. What that means is in the visible region, 400 nanometers to 700 nanometers is what?
Visible.
Visible. Now, before 400 is what?
Infrared.
No.
Ultra
UV.
UV.
And after 700 is what?
Infrared.
Infrared, IR. You need to know at least this much. Now, the next interesting thing is that when in an atom, how do you get the flame test? Do you remember the flame test? And then do you remember looking at the lights, the gas tubes that were excited through the spectroscopes? Do you remember that?
Yes.
Now, an atom, when you provide energy to the electrons in an atom, correct? When you provide energy to an electron in an atom, an electron gets excited. When it gets excited, it goes to the higher energy level. It doesn't belong there and it wants to get back. When it wants to get back, what does it have to do? It has to give out the energy in the form of light. Now, when the electron drops from any other level to the n is equal to 2, the light given out is in what region? Visible region. Now, if the electron drops to n is equal to 1, what region is the light given out? UV. If the electron drops to n is equal to 3, what region? IR, infrared. Now, in the textbook, open up your textbook, page 103, 103. They can open it up so that it doesn't interfere your recording. Page 103, 103.
Oh, you
Open
can
up the
do-
textbook, page 103. Okay, there are many textbooks around. If you don't have one, there's one in the back here. Alice, behind Medha.
Oh,
There are a couple of textbooks there. You. Open up to page 103. You see that diagram there?
Yeah.
You see the diagram?
Yes.
Yes or no?
Yes.
Can you show it to Medha so that she gets it in the recording? What diagram I'm talking about? Yes?
Got it.
Okay, good. Now, hey, if you have to do a job, you have to do a good professional job here. So now, okay, what if you open up AP Chem textbook? You're not going to find it in there, my dear. Get up, walk a little bit behind. There are so many chairs underneath where there is a textbook. Dave, in 2 years you go to college. Okay, really? That much of a time to get a textbook? Fine. Now, page 103. Now, what you see there is, what are they showing there in the diagram?
Lines.
Lines, great. I love those lines. N is equal to 1. N is equal to 2. N is equal to 3. They are showing the drop of electrons from orbits from above to n is equal to 2 or n is equal to 3. It's called, each series is called Lehman, Balmer, Paschen, Brackett, and Fun. Do you have to know the names? No. You don't have to know the names. But what is the energy difference is what you need to know. Question, Medha.
How does it get the energy to go up to the?
It
Oh.
either you provide it, you hold it in the burner,
Oh.
or you electrocute it.
Oh. Okay.
Remember?
Yeah.
Okay. Now, what do you need to know from those lines? There is a big energy difference between which two levels? 1 and 2. And what about 2 and 3? Not as much. So now you will have to make kind of the questions can be do you think who will take more energy? Like the jump between 1 and 2 will take more energy, or between 3 and 4 will have more energy? Something like that. As long as you can read that graph or that picture, you should be good.
Wait, so
Yes.
the energy level 1 has a higher energy.
Look
than-
at the picture.
Yes. I
There
got
you
it.
go. Good.
Okay.
Lucas,
When is it turned to infrared and ultraviolet?
when it drops from any other level to 2 is visible. From top to 1 is ultraviolet. And when anywhere from top to 3 is infrared. Look at that picture on page 103. Question.
Will this chart be on our?
It'll be given to you in the question.
Okay.
If they ask you that question.
What if it drops to?
It's still going to be.
Anything
it's good.
above
it's going to be infrared
Yeah.
only. It's going to be infrared. Okay, these kind of questions. Okay, nobody's going to ask you to solve the Rydberg's constant, which I made you do in the class, if you remember.
Yeah.
But nobody's going to ask you to solve any of those questions. It'll be theoretical knowledge only. Good. Now that brings us to electronic configuration. Correct? Now, which is, if the configurations that, the hardest thing that we can ask you is, nobody's going to ask you simple ones. The ones that we might ask you are going to be, hey, what is Ca plus 2? What is the electronic configuration of Ca plus 2? For that, let's start off with calcium. What is the electronic configuration of calcium? As a class, please.
1s2, 2s2, 2p6, 3s2, 3p6, 4s2.
Good.
Oh,
Now,
4s2.
they are asking you for Ca plus 2. What does Ca plus 2 mean?
2 less electrons.
2 less
2 less
electrons.
electrons. That means in order for this to become plus 2, it has to lose 2 electrons. Correct?
Yeah.
So this is the electronic configuration for Ca plus 2. Now, take your time and do it properly, because I will see people ending up writing configuration for calcium because they forget that Ca plus 2 is loss of 2 electrons. Question?
Couldn't you just look at the periodic table?
You
it's
can.
Like it has 2 more, so you just go back to and then find the
You
electron
can.
configuration for that.
Absolutely you can.
'Cause
But
CA
then the
plus 2 is
options
just
are
more.
this, so you need to pick this, right? You can. What you said is absolutely correct. Kevin,
What about the laws regarding electron placement?
what about those?
Oh, like the Hund's rule.
Oh, very good.
I don't
Hmm.
remember any of them.
Right.
Oh,
So Hund is the creepy bus guy, and then there's
Okay,
the party
who's the
guy.
landlord?
Party.
Afbao owns the apartment. So Afbao says the crappiest apartment goes first. What does that mean?
Bottom A.
Lowest energy is filled first. Then comes who?
Hunt.
Hun.
No, it's not.
The bus driver. You're right, Hunt's rule. The bus driver, the creepy bus rule. You do not pair up with somebody when the entire bus is empty. There's nobody in the bus. You don't go and sit next to the one person in the bus. You do not pair up. You find another window seat. And when there are no seats left, window seats are all gone, then you pair up. And then the last one is Pauli's exclusion principle, means opposites. If it's upspin, then you pair it up with the downspin. People of opposite spins are put in the same room or same level with each other.
Oh, Polly's the roommate guy.
Pauli is the maintenance guy.
Yeah.
You're right, you're right, yes.
Let's say if you were trying to find the electron configuration of cobalt,
Mm-hmm.
and you were saying cobalt plus 1 or plus 2,
It loses from 4s2.
yeah, you don't take away from the d orbital.
Correct.
Is there a reason
Understand,
for that?
cobalt is 3D, okay? 4s2, 3D, 1, 2, 3, 4, 5, 6, 7. 3D 7, correct?
Yeah.
You do not lose from the d orbital, you first lose the 4s, because 4 is a bigger number, it's the outermost orbit, and that's why it loses from the 4s instead of 3d.
So then, like, if
If
it
it
were
was
like
4P.
-3, like if you were done with 4s, then you would go to D, right?
Correct. But
if it was in P, you would lose from P first because it's the same number.
it
as
generally
S,
goes
right?
from, won't go from P. Then
Like,
then
what
it'll
about
be
if it was
3D.
R?
Okay, 4S and then it'll move from 3D. I heard, yeah.
Huh?
What happened?
Oh, I'm here to listen.
You're here to listen, okay. Kevin Cox. I never knew his name when he was in my class. I always blanked out on his name. But I knew, he was in my class. He was used to work in the back there, right?
Yep.
Yep, I know that. Okay, so you always lose from 4S and then the 3D. Sounds good?
So you always lose from the S and P orbitals first.
Correct. Because they are the valence electrons, they're the outermost orbit, even if 4S is lower energy than 3D, always. Good. Any other questions? No?
Would it, orbital notation?
That's the flowers you have to draw. Energy notation is this.
Wait, Elijah. Can you slash?
1S,
Can you
2S,
slash?
2P, that thing. Okay, next. Trends, we're getting there. Periodic trends, after this we get into trends. What are the 4 trends? The size, atomic size, ionization energy, electronegativity. You just have to know the trends.
Met-
I mean, there's nothing more to it. Now, what is the word? What happens to the size as you go across the period?
It gets small.
Why?
Because the radius.
Why, Kevin?
VFX is
What is the word I'm listening for?
Effective nuclear.
Nuclear